Dr. Sundar Vedantam, and he is the Director of Software Development in the Data Platform Group of the Intel Corporation in Allentown, PA. He's a lifetime member of the ACM and is involved in promoting the organization both inside and outside his company, which is of some renown. His skill set and experience cover a wide range of telecommunication-related domains. His team's currently involved in delivering highly optimized firmware layers that run on complex system-on-chip devices that power mobile networks. His research interests include network traffic and congestion management, high-speed networking, security, and theoretical computer models, areas in which he holds patents and has published papers, book chapters, and articles. He received his PhD in computer science in 1997 from Louisiana State University. Currently, he's part of the ACM Distinguished Speaker Program, where he lectures about the societal, business, and ethical implication of some of the most advanced technology in use today and in the future. So today, Sundar will present his lecture, Thought Experiments, an Inexpensive Tour of the Entire Universe, based on his book of the same title, where he introduces a wide range of thought experiments. The book covers areas such as economics, ethics, physics, mathematics, medicine, democracy, an important one in these times, artificial intelligence, and machine learning. So take it away, Sundar.
To begin with, we are all part of ACM, so I don't need to talk too much about it. But this is part of the ACM DSP program. I've been a lifetime member. I do try to deliver the talks by physically going to locations as well as through video conference calls like this one. So I'm grateful to ACM for supporting this endeavor. I'm glad the remote option has been regularly added now. A lot of people are doing it, which reduces the cost, but also makes it much more accessible to a lot more audience. So I appreciate the notion, and my thanks to ACM, and please do support it wherever possible. Before we dive into the book itself, just wanted to give some background as to how this book came about. Like we might have met many other people. I came to US some 30 plus years back, and back in India where I grew up, this is my elementary school. I went to in the early 70s. More than a decade back, I did go back to visit the school. While there is a lot of growth in some parts of India, the rural areas still have schools of this kind. So I didn't see any phenomenal difference on skyscrapers in that little town where I went to this elementary school. And this is a sample of my elementary school classroom. Often kids used to sit on the floor, and the teachers who are standing behind this is a government school, right? So they all teach, and there is very limited amount of resources, books or teaching aids or anything else that are usually available. Of course, you would see a wide range of different kinds of schools. There are extremely expensive high-end schools where students go on field trip to international locations every year and so forth. So those are definitely there, but this is much more common in the rural parts of India. In my family, I was the first one to go to college, and since my parents didn't go to college, there wasn't any notion of keeping a stack of books at home or easy access to library, anything like that. The school that I went to didn't have a library at all. But even the local libraries used to be with like minimally stacked books and so forth. We were all happy, we had good fun, but I didn't really know what is it that I should be reading at all. So over the years, I kept wondering, I mean, how do you change that, right? How do you go around providing the right kind of material to students so that they'll find it interesting, not too boring, textbooky thing, but fun thing that they can talk about, discuss, that will pique their interest, that keep them engaged while learning a lot of interesting notions, concepts, details, experiments. This is actually my middle school located in a different town. As you can see from the date, this is even like 10 years back. This was taken in like 2008 or so. This is literally the bench and position where I used to sit when I was in my 7th grade. So I took my son who just graduated high school. So that was like more than 10, 11 years back, just to show him my school. You can see the school being fairly barren, not much there. And it hasn't changed a lot. So this picture was taken just last December when I went to the same place. So this is the same school. So the point being, internet is there, access may be there, but there is still not very clear direction material as to what kids and people should be reading and what will stimulate their interest and lead to interesting discussions, etc. So as a result, I thought rather than just complaining, I should start contributing with worthwhile material that will be of interest to students. So then came across this website called solvanam.com, which means word forest. Sol is word and vanam is forest.com. It's a Tamil magazine website in US run purely by volunteers. They don't require any like login ID, password. They don't show any advertisements. It's been set up just to raise the level of discourse in the language Tamil. So they have been publishing pretty interesting articles on science, STEM related topics, as well as some short stories and things like that, but not much about the regular movies or politics or anything that's the standard fare in most of the local linguistic websites. So I started contributing to this website 7-8 years back, and then
hey,
yes.
Sundar, I've lost your screen. All I see is black.
No,
so
actually, yeah. Yeah. Are you able to
Thank you.
see the thought experiment?
I see it now.
Yeah.
I see it
actually,
now.
that screen was indeed black, just with that solvanam.com site at the bottom, waiting for me to click. So
I'm sorry, I just misunderstood that.
No. Actually, it wasn't obvious, probably. Sorry about that. So I wrote a series of articles related to thought experiments in various domains in Tamil. So that was a big hit. And then I collected them together, added some more material, and published it as a book in Tamil. And of course, ebook accessibility may not be that easy. So I printed out a couple of hundred copies using my own money and then distributed it to schools all over Tamil Nadu. Hopefully that's stimulating some younger minds and people are finding it interesting to play with, right? And while that was going on, I was looking up the regular Amazon Googles to see what kind of books exist in English for thought experiments. I noticed that there are a lot of websites and blog posts that talk about maybe one thought experiment at a time, but I did not see popular reading material type thought experiments book. There were a couple that were kind of probably too dense, too deep, meant for grad students at that level. The book itself is like $100. There was a couple of books of that kind. And then maybe there were some blog posts, but I didn't find something in between, a popular book on thought experiment that does cover a wide range of topics. So for the past 3 years, sat down and slowly worked on translating the book into English. And of course, since I've taken additional time, also wanted to raise the quality of the book. And so I got a lot of individual drawings commissioned through a friend of mine in India, got those included. And I knew I won't be making money off of this book, and that was never the intention. But if I give away the book for free, people don't take it seriously. So I just put like a $4 price with all the money, every penny to be donated to the solvanam.com site. So while doing that, I also wanted to make sure the quality of the writing is good. So in addition to getting it proofread, things like that, I wanted people to really read and challenge me to make sure it's logistically correct, the flow looks good, and so forth. And I presume bigger authors who work with big publishers, they may get good staff assigned to do all that. And I didn't want to go that way because it might become pretty expensive. And even when I wanted to use some drawings, for example, there was the trolley experiment related drawing that I wanted to use from a New York Times article. When I contacted them for copyright, they basically said it's $150 for that one diagram, even though this is a kind of a volunteer nonprofit venture. So I kind of gave up, and then got those drawings redone myself through somebody I knew. And later on, in addition to asking my friends, I actually went to my grad school thesis advisor, and he has become more of a friend now. So I sent him the draft, and he really read through the book and took me to task in every little error or some inconsistency in logic or some fact that's not looking right, etc. So Dr. Trahan, he was my MS thesis advisor and PhD committee member, so who has become a good friend. So he helped a lot to clean up, polish the book, and raise its quality. Right. So with all that, finally the book came out a couple of months back. It's on the web. It's available on Amazon, Google. You can buy a paperback for like $9. And as I said, I'm not making any money, and all the money will go to this website. So please support the cause if you can. In the book itself, the thought experiments are spread all over the domain. So as James originally mentioned, there are fields, I mean, there are experiments related to ethics, democracy, medicine, physics, math, et cetera, that I've tried to cover. What really appealed to me was there are these large experiments, maybe International Space Station or the Large Hadron Collider, things like that, that are that are really needed. They do good work. They find good information for us, but they are running into multi-billion-dollar projects. And then on the other end of the spectrum, you have these thought experiments where you literally don't need anything. You just sit around, think through, then use various questions that you pose to analyze any problem that's out there, right? And it also provides a nice thread to link together using one single framework any kind of topic that you want to deal with, that you want to talk to school children, you want to talk to your family and friends. And so it was always intriguing, interesting to me as to how many different areas that one can touch with this simple tool. And so I've tried to string together a lot of different thought experiments into this one book. So in the first, we'll just walk through 3-4 thought experiments in this talk, and there is a lot more in the book that you may find interesting. So the first one is the Chinese room experiment. Some of these you might have heard through your other interactions, your college courses and so forth. Hopefully you haven't read all of them. So the first one, we'll call it, do you know Mandarin? That's the title of the thought experiment. This was proposed in the 1970s by John Searle. It is to discuss what is possible in computers, and can they really gain consciousness and compete with human beings and so forth. That's the purpose behind this thought experiment. So this is the setup. So there is a person inside a room, and there is an input and output interfaces in the room. So you can imagine there is that input is a hole through which a sheet of paper can fall down, and then there's a lot of data available, and there is a rule book, and then there is an output where the person sitting inside can write something and then drop off whatever the answer, whatever he has written, so that the people outside the room can pick it up, right? Then the rule book that he has is extremely detailed, and it has things like, if you see this particular Mandarin script, Chinese letter characters, then followed by this shape, followed by this shape, then as an answer, you produce this shape followed by this shape, right? The person himself doesn't read or understand Mandarin, but using this rule book, he can take the input in and then just look through one hieroglyphic icon by icon, the symbol by symbol. He can then go and match it up to the rule book and then figure out what the response should be. So there could be questions coming in from the input interface, or it could be maybe a story being told, and then the input is asking this person to write a summary of it, or the interpretation of what the idea behind it, and so forth. Whatever it may be, using the rule book, this person just draws those characters one by one, puts together the answer, and then puts it out on the output side, right? And then a real person who's on the outside the room picks it up, and he's the one or she's the one who posts the question, and then they get the answer back and then see how precise, how elegant, how eloquent the answers are, right? So it's all correct and it makes good sense. So now the question is, can the person inside the room be considered as one who knows Chinese, right? That was the question. If I get facts like, oh, I mean, how quickly can they do it, and so on and so forth. A lot of people immediately think, oh, this is a nonsense question because he's just following the rule book. How can he be considered knowledgeable in Mandarin? So he doesn't understand what he's doing. The whole purpose of the experiment is to map it to modern computers. And so the strong AI group of scientists usually think this is all the computer can do, right? So you are giving it a rule book, which is the program that you have written, and there are input that's coming in, and based on the program that's given, it is manipulating that information and then giving you some output. So beyond that, the computer can never ever develop a real consciousness. It can never understand what it is doing, and that's how it will be till the end of time, right? So that's one camp. Of course, the other camp argues that the question is the way it is posed, or how this whole environment is viewed, is incorrect. So if you are thinking of just the person here, that is equivalent to maybe just the CPU in a computer, which is just executing a sequence of instructions. But if you take the entire room, that includes all the data that's sitting there, the rule book, which actually has all the information as to how one need to respond, then the human being who's reading, writing, taking the input and providing the output, then the whole system, the entire room containing all the pieces together does know Mandarin. Maybe the bulk of that knowledge comes from that rule book, but since it's part of the whole system, the system knows Mandarin, right? And that is their argument. And so they argue, by the same token, a computer which has enough information and behaves and answers and responds just like a human being is essentially equal to a human being. And you can say that system in its entirety has consciousness, has self-awareness, and so forth. And they even go to the extent of arguing, even if you take an individual human being, what do they do in the end? If you narrow it all down, it becomes like chemicals and neurotransmission and muscle movements and so forth, and that's all the human being is. And beyond that, at some point, if you say the self-awareness and consciousness pops up from this chemical electrical sequence of actions and reactions, then the computer that can mimic that perfectly can also can be stated as having similar kind of self-awareness and consciousness, right? And of course, that has led to a lot more interesting debates and tests. You might have heard about Turing test, which has been designed to set a threshold at which computers, when they mimic and mimic human beings and respond to question and answers, if the person on the other end are not able to distinguish whether it's really a human being or a computer, and the computer is supposed to have passed the Turing test threshold. And that's been a continuing effort to keep improving that threshold and what it can do, and so on and so forth. So originally, the idea that was proposed to debate the strong AI and weak AI ideas to analyze whether computer can have consciousness now has actually seeped into the popular consciousness, and there are a lot of linguists and philosophers and others have picked up on this particular thought experiments to analyze, okay, if that's the case, how does it actually apply? What happens to an animal? What happens to actual human beings themselves? And where does consciousness arise? And so on and so forth, right? So there are books on it, and there is so much more to talk about this itself, but we'll just move on to the next thought experiment in the list, right? The next one I chose is called Hilbert Hotel. David Hilbert is a 20th century German mathematician. He wanted to explain what infinity is, and so he came up with this notion. We all know, we've all been to school, so we know there is 1, 2, 3, and then the numbers keep going on, and then eventually it goes to infinity, and that is the biggest number out there. Okay, if that's the biggest number out there, if you ask, is there anything bigger than that, or what happens if you multiply it by 2? There's no clear answer. It's a weird number, right? So he wanted to explain that to his students and the popular audience. So he came up with this notion of this Hilbert Hotel. So there is this hotel, and that hotel has infinity number of rooms available to it, right? So their tagline is, we are never out of space, or we always have room for you. So one day that hotel is full, there are people in every room, and then there happens to be a mathematical conference going on in that town, and so there is a bus bringing in a whole bunch of mathematicians who are coming to town to attend the conference. And the weird thing about that bus is it has infinite capacity in itself, right? So the bus brings infinity more people to town, and they all need to stay somewhere, and so the only place they find is the Hilbert Hotel. So they all show up, and the hotel manager looks at them, and he knows the whole hotel is full, but he says he can still accommodate all of them in there. And how does he do that? He simply uses the public address system, saying, hey, everyone in every room, take your room, multiply it by 2, and then move to that room, right? So that's your new room. So person who's in room number 1, they go to room 2, then room number 2 person goes to 4, and then room number 3 person goes to 6, and so on and so forth. So everybody doubles their room number and then go over to those rooms. And once they do that, then all the odd numbered rooms becomes vacant. And so all the people who came in, they all get assigned to those odd numbered rooms. And when they do that, it's since this goes till infinity, the number of even numbers and the number of odd numbers themselves are infinity. And so this whole busload of people came in, they all can be accommodated in the same hotel, even though it was previously full, right? So that's the weird nature of infinity. So he was using this idea to explain this to his students. And so then the ante got upped one more level. So there could be a second conference on computer science, so that brings in one more boatload of people, infinity people. And again, you can go through the previous algorithm of asking everybody to go to that double their room number. And so in addition to that mathematics conference infinity people, there's this computer science infinity people can also be accommodated into the whole same Hilbert hotel, right? So if there are one set of infinity people coming in, you can keep executing that same idea and then keep accommodating them again and again. Now, let's say there are not only mathematics and computer science conference going on, but there is also an ethics conference, a medicine conference, a democracy conference. There are infinity conferences going on in town. Don't ask me how, why, but somehow it happens. And for each one of those conferences, there are infinity number of people coming in, and they all need to be accommodated into the hotel, right? So how do you go about doing that? So of course, the manager can pick up just the first bus. There are infinity people, accommodate them all, and then move on to the second bus and so forth. But the first person on the second bus, this lady, she starts complaining, saying that, hey, this is not going to work. The first bus itself has infinity number of people. So by the time you finish accommodating them all, that will be infinite amount of time. So I have to wait here forever, and I'm never going to get accommodated. That's not fair. I need to tell me in a finite time when I will get into my room, right? So the manager comes up with this plan. So he asks people to move up, and then as the room gets vacated, he's going to accommodate this person first, and then the second person in the first bus second, and then instead of going to the third one, he'll come and accommodate the first person in the second bus next. Once she's done, he's going to go to the third bus and pick the first patient, then come back to the second bus, second patient, and then the third patient third passenger in the first bus, and so on, right? So this arrow sequence shows what is the order in which he's going to start allocating rooms for all the people who have showed up. The idea behind this is you can see every bus is going to be picked up. Of course, there are infinite number of buses here, and there are infinite number of people here. But slowly, you can figure out when, how, who is going to be accommodated, and so forth. So with this notion, he said, yeah, I can accommodate all the people who came in into the hotel, no problem, right? And that was the discussion that was going on with David Hilbert and his students and the popular audience at that time. Then came George Cantor, who's actually a senior to David Hilbert, more like a guru to Hilbert. And he said, well, all this sounds good, but it doesn't really work if you try to accommodate every kind of infinity into this one Hilbert hotel that has infinite number of rooms, right? So people are asking, what are you talking about? This hotel has infinity rooms, so what can be bigger than infinity? There is nothing more that we really need to worry about. Then he came up with this idea, which is, it's probably like 100 years old, but even now I find it so elegant. A simple proof to show that all infinities are not the same, right? So he came up with this notion of taking all the fractions between 0 and 1. We know that alone could be infinity. And then there is this natural number, 1, 2, 3, 4, going all the way up to infinity. So he was comparing the natural number infinity with all the fractions that exist between 0 and 1 infinity. And he said these two infinities are not the same. Right? The way he proved that is, take any one of these passengers. So for example, this one. So this lady came on, she's the first passenger on bus 2. So maybe you can take 1, that's her bus number, and then, her passenger number, and then 2, which is her bus number. So divide that 1 by 2, then you get 0.5, right? So take that as a fraction. So similarly, since the numbers range infinity to infinity in both direction, you can keep creating such fraction for every person out here. Some may be whole number, but just pick up the ones that are all fractions and just set them up. So in theory, you would think you will get all the numbers between 0 and 1. And after that, he said, let me show you something. Let me go to the mathematics section. This is David Hilbert, and this is George Cantor, and he came up with this idea of listing out all the fractions that are out there. So let's say just at random, this is a fraction, it's 0.4 something something, and then this 0.27 something. So there are these series of these fractions. And he said, list them all out. Think of all the fractions between 0 and 1. Then take just the first decimal after the decimal point in the first fraction, which happens to be 4 here. And then the second decimal in the second one, that's 7. The third one from the third fraction, that's 8. And then the fourth one from the fourth fraction, that's 5, and so forth. And then construct a fraction that way. So that is 0.4785 and so on and so forth, right? And he said, just change each one of these digits to something else. So maybe 4 becomes 6, 7 becomes 3, 8 becomes 9, and 5 becomes 1 something, whatever. So just replace it with another a single digit number in there. You would see, since it is point something, it's definitely still a number between 0 and 1, no question. But this number is going to differ from this first fraction in your list in the first position. Then it's going to differ from the second fraction in the second position, and so on, because you intentionally picked up the numbers and you changed each one of these digits to something else. So this is a brand new fraction that you have constructed, and that is not there in your list because it differs at least in one position from each one of the fraction that you have, right? I hope this makes sense. The details are there in the book if you want to look that up, or it should be online. What he was trying to show was, if you are trying to map each one of the fraction between 0 and 1 into the natural numbers 1, 2, 3, 4, 5, you will run out, right? So the infinity of the number of fractions that is between 0 and 1 is much bigger than the infinity that you get to by counting just 1, 2, 3, 4, 5, right? So it's simple but a very elegant way of showing that all the infinities are not the same. Moving on, we'll go into a paradox. This is called Newcombs Paradox. This was like such a simple one that made a lot of people go crazy. So in this one, there is a TV show. You are invited to come attend the show as a participant. And the show is very, very simple. You just go sit there, and then there is a box one that is made of glass, and you can see there is $1,000 sitting inside. Then there is a box 2, which is made of iron, and so you don't know what is inside. So that second box could have $1 million, or it could be an empty box, right? You don't know whether it is contains anything or is it empty. So those are the two boxes. All you have to do is you just need to pick just one box or both boxes. You just pick what you want, but you are told, just like the TV game show Deal or No Deal kind of thing, there is a weird banker here. That banker has some sort of clairvoyance, and so he knows what is it that you are going to pick, right? And if he thinks you are going to pick box 2, he's going to leave it empty. Sorry, if he thinks you're going to pick both boxes, he's going to leave that box empty. But if he thinks you are going to pick only box 2, he's going to put $1 million in there, right? That's it. So you are told that, and so you are sitting there in front of these two boxes. You can clearly say box 1 has $1,000. So your goal is, of course, to get as much money as possible. So would you pick just box 1, or would you pick both box 1 and 2, or would you pick just box 2 only, right? That's the question. This was again posted in like the 1970s or so, and it really drove people crazy. Everyone thought they know the answer for sure. This is how it should be, and how come the other side doesn't get it at all, kind of thing. And so some people did argue, since the person somehow knows, you have to just pick box 2 only because you want to go home with $1,000,000. If you end up picking up both boxes, you are going to get only 1,000. There is no point doing that. And of course, nobody picks box 1 alone because that doesn't make much sense. So it's either box 1 alone, or you end up picking both boxes, right? So those are basically the two camps going back and forth. So a lot of people say, hey, whatever happened, the boxes are sealed and it's sitting right in front of you. Nobody's going and changing the money inside. So what is there is there. So you should just pick both boxes, right? But a lot of people say that's not the right answer. You should just pick only box 2. So there's been a lot of debate going back and forth, including Newcomb himself thought one way first and then changed into other way, and so on and so forth. And the interesting thing in this paradox is it comes up in the subsequent notion of this thought experiment idea called brain in a vat, right? So in general, we know we get all our perception of the world. How do we perceive the world is through our senses. We see stuff, we hear stuff, we taste, feel, and smell things. So from those 5 senses, whatever input that comes in, that's all we use to see the world, perceive the world, and deal with the world all the time. What if there is a weird scientist who somehow, when you're sleeping, took your brain and then he put it in a special vat and connected it all with a bunch of electrodes to a computer, and then he feeds the exact sensory input that you would normally sense into your brain through some high-end system, right? Question is, how would you even know if you are in some such system perceiving only what the scientist wants you to perceive, or are you really in a real world, right? Of course, you can say this is all some nonsensical sci-fi thought experiment. What's the point? But you really think through it, it's really hard to say how you would prove to yourself that you are in a real world. Because even when it comes to like virtual reality glasses, for an example, right? Once you start wearing it, you can, for example, be fed images as if you are standing at the tip of a well or a hill cliff or something like that, and your brain really starts processing it, and you would find it hard to walk around the room even though you know consciously you are in a simple room, right? But if you really push it to a point where you are not really sure, you did not put the goggles on with clear understanding of where you are, how would you even understand that what you are going through is a simulation or is it a real world? That may not be really clear. And in a very interesting way, this idea ties back to the previous Newcombs paradox, because those notions like maybe somebody could take a copy of your brain, or they could do some sort of a simulation, and that's what the banker used and made you play the same game in a simulation where you either chose just the box 2 alone, or you pick both boxes. And in that simulation, if you had picked both boxes, he made sure that the second box is now empty, right? So in the real world, when you play it, if you try to pick both boxes, you will go home only with $1,000. So that's how the banker was able to predict what you were going to do. So if some such thing is really possible, then it comes back to the notion of when you are playing it now, are you really playing it in the real world? Or is this a simulation that the banker is running at this point? right? So when you analyze it that way, then people start saying that, hey, that is why whether you are in the real or simulation, you are not sure. You are not sure if you are a brain in a vat. And so you should always play it safe and then just pick up box 2 alone. That way you are sure of getting $1 million. And in the real world, if your other self really plays and messes up and even picks up both boxes, maybe she or he will end up getting 1 million plus $1,000, right? That might be a good thing. So since you are not sure whether you are a brain in a vat or you are in the real world, you should play it safe now and pick only box 2, right? So that debate was going on, and it was nicely tied to this brain in a vat thought experiment. So in this one, that's why the brain in the vat has to say, I'm choosing box 2 alone, so that I'm good now. And if it's in a simulation and the real world person picks both boxes, it's still good. Right? Many of you may have heard about this Schrodinger's cat idea also. This was a thought experiment proposed by Erwin Schrodinger, who's a physicist in the 20th century. If you normally take any of us, like a human being or a real animal that we normally perceive, we know where we are, what we are doing, because we all work in the confines of Newtonian physics, right? So we are all big enough entity, so we can clearly say a person, Joy, is whatever, 120 pounds. She's riding from Allentown to New York in a bus, whistling Dixie at 65 miles an hour, etc., etc. So we know the position, the speed, all the details of an individual human being very precisely. But if you really start diving down to lower and lower strata at an atomic level and subatomic levels, we no longer have a clear idea of where the subatomic particle is physically located. So it starts to become more like a cloud with some probability distribution describing where that particle is and where it is moving, what's going on. So if you really describe a human being in that kind of a notion, it becomes something like Sundar is existing like a cloud across Pennsylvania and Ohio and like the Northeast United States with such and such probability kind of thing. And to a lot of people, when that quantum physics ideas started coming into play, it didn't make much sense at all. The Copenhagen explanation, that is the name of this particular idea in quantum physics, had started saying the particles exist in a probability cloud, but if you really start even looking at it, observing that particle, then immediately that wave function collapses, and so it looks like the particle is at one particular location at that instant of time, right? So Schrodinger didn't like this idea at all, and that's why he proposed this thought experiment. And he was saying, if that is true, then imagine this. So there is a iron box, and of course this is a thought experiment proposed in I think the 30s. And so maybe there was no PETA, but there was no cruelty done to any real animals, so nothing to worry about. A cat is put inside this box, and there is a bottle in which there is some poison. That if the bottle is broken, it's going to just evaporate and spread into this box, right? And then there is a radioactive element with a half-life period of like 1 hour, and that is put in here. And there is a Geiger counter that is watching that radioactivity if there is a particle emission from that material that's stored there continuously. So the box is closed and you are outside. So the idea is, if there is within that 1 hour period, if there is an emission, the Geiger counter is going to notice it and then trigger this hammer, which is going to go break the bottle. And so the poison is going to seep through the container, and it's going to evaporate and kill the cat. Right? So you are sitting outside. the probability of that particle emission is only 50-50. So you don't know whether it's going to go out and result in the cat getting killed, or maybe it won't happen and the cat will be alive, right? And of course, at any time, if you open the box and look inside, you will immediately see whether the cat is alive or not. It's easy to see. What Schrodinger argued was, because there is a 50-50 probability, it's possible that the cat could have got killed, or maybe it's alive. So the Copenhagen explanation for the atomic particle sounds like, within the confines of that box, the cat is simultaneously dead and alive, which cannot be true. And that's how this whole quantum physics ideas sound to me. So it doesn't make any sense to me at all. How can, when you really look at it, the wave function collapses and then suddenly the particle details become very clear and visible, right? Doesn't make sense. Like, the cat cannot be dead and alive at the same time. And of course, there were additional arguments and discussions further into this, saying whether it is the cat, or when is it the Geiger counter which is the one deciding, and is it the appropriate comparison for a real cat-like animal? Can it be mapped to a subatomic particle, and so on and so forth? But it very vividly, very nicely conveyed the idea of Schrodinger to a multitude of people and led to pretty interesting discussions. And eventually it got into the pop culture parlance. So you can often see it being appearing in like TV shows and movies and things like that. And I won't get into this. This is one of my favorite thought experiments that I have talked about even in that ethics talk that we did before. Basically, a Unmoor Trolley coming in that may kill these 5 people, and you are sitting here and you can switch the track, and would you do that to go redirect the trolley to go kill this just one person to save this 5, right? So this has originally proposed as a thought experiment, has now is becoming real with self-driving cars and so forth. So I've talked about that in the book, and there is even a website called Moral Machine run by MIT. They are constantly taking survey input and presenting the results to see how people react to this thought experiment all over the world. Right? Pretty interesting. And it even goes beyond explaining existing notions alone. So this one, I found that to be very intriguing. There is again a computer science professor called Peter Koenig. He was wondering, we often do thought experiments like, if you have some superpower, what would it be, right? And what would you do with it, and so on and so forth. So he really thought about this, and then we are all very familiar with various medical prosthesis devices coming in to replace some sense or a limb or something that a human being has lost, right? So maybe there is an accident, somebody lost a hand, and now we have a prosthesis hand. And it even goes to the extent of giving people maybe replacing their vision, eye ability, or like there are cochlear implant to bring back hearing, and so on and so forth. That is all well and good. We talked about the 5 senses, and something doesn't work, and then we are making them whole. That part is okay. But Peter Koenig wondered, can we really give human beings an additional new sense that they never had ever before, right? So he came up with this idea of a belt in which he attached a dozen pager-like vibrators. They are permanently attached. You can't take anything out. And you wear that. So he actually made a bunch of his grad students wear them for a month continuously, 24/7, right? And the way it works is whichever part of your body is facing the north, that particular pager box alone will continue to vibrate permanently, right? You cannot stop it. It will keep on vibrating. So if you are facing north, naturally the pager that is right in front of you next to your navel, that will start vibrating, right? And then let's say you keep turning towards the west, then the pager on your right side hip will start vibrating. And then if you are facing the south, and of course the exact pager at the back of your body will start vibrating. So as you keep turning around, that just one pager, whichever one is closer to north, that keeps vibrating all the time, 24/7, right? The grad student said when they started wearing it, for the initial 2-3 hours, it was really annoying because it keeps vibrating and making this like funny sensation around your hip all the time. But within not even a day, within like 3-4 hours, they got adjusted to it quite comfortably. And then for within a day or two, that information start going into their brain consistently, and the brain knew what is coming in, and it gets used to it, get acclimatized, and then processes it on its own very nicely. So the human brain, as long as any sensation, any signal that's coming in, if it is consistent, right, then it can always make very good use of it. If it's inconsistent, of course, it'll be very difficult. But as long as it's consistent signal, it can immediately start processing, even though you are never familiar with that particular signal before. You never had that before. And so the grad student said after a day or two, they felt completely comfortable having that. And as they went about their daily routine, let's say they are biking around, as they go from apartment to the department, or in the evening they are cycling around, they can keep thinking, they subconsciously knew where north is. And so the map of the whole neighborhood starts forming in their mind continuously, right, on its own, without them having to do much. So they suddenly became aware of, as they were biking around, hey, my department is on the back on the right side, that's where it is. And as they make a turn in their bike, they can literally see the department kind of moving around at the back of them. It's on that other side. They knew where it was continuously. So they were wearing it for about a month, and after a week or two, they many of them felt they could never get lost anywhere in even in a new city when they go somewhere, right? So they always have the sense of where they are to orient themselves day in, day out. And of course, after a month, he said, the experiment is over. All of you give your belts back. And they handed it over. And many of them said they really felt like a loss of some sense that they had, as if they lost their eyes or ears or something like that. They didn't know what it was, but they felt a big sense of loss in them. This really goes to show how the plasticity, it's called neuroplasticity, right? So how plastic brain is and how it can pick up new ideas. And the whole notion and this thing came up simply because Peter Koenig was doing thought experiment as to, hey, what kind of superpower can I get and what will I do with it, right? So it was really a cool thing that I came across. So we just touched upon some, and beyond that, the book really talks about many more domains of thought experiments in ethics and medicine and democracy and feminism, economics, and so on and so forth. I've tried to string them together in a like very easy to understand, simple party conversation or like classroom conversation kind of prose. So hopefully that will open up a lot of new ideas and lead to pretty interesting debates. And why should we actually do that? Is mainly because this is a unique human ability, right? Human beings have this prefrontal cortex, which gives us the ability to hypothesize, to think through what can potentially happen in a hypothetical scenario. This is not supposed to be a capability that other beings, other animals, or others that are around us have. It's a unique human ability. So it makes all the sense to put it to good use, and that can potentially lead to a lot of new products and services. So we can, for example, the book talked about how Einstein's theory of relativity has its impact on how GPS works today, right? So without that, it may or may not. So there are all kinds of products and services that can potentially come out of thinking through. And of course, in the end, it's going to make us all more human. You can relate it to anything and everything. The protests that are going on out there, there are discussions in the book related to how will you structure a society, how will you form laws and rules and regulation that will uniformly apply to all the people in a society, irrespective of what gender, skin color, rich, poor, religion, what kind of background that they have, right? So all it takes is think through, sit down and talk to people, and that can lead to some not only really interesting discoveries, but uplifting our own society as well. Thank you so much.